Given the function f of x in the point q, find all the points p on the graph of f of x such that the line tangent to f of x at p passes through q. Okay, so we need to first find the derivative, f prime of x. And we'll use the definition of the derivative to figure that out. Let me write that down really fast here. Okay, so that will give us, that's approaching 0, the limit as h approaches 0 of x plus h squared plus 7 minus x squared plus 7 all over h. So f prime of x is equal to, let's expand that out, so we would get x squared plus 2xh plus h squared plus 7 minus x squared minus 7 all over h. Let's see, we can cancel out some things here, which would give us, that's equal to 2xh plus h squared over h. I guess I should go ahead and write the limit there because we haven't actually taken it yet. But when we can reduce it one more time, we can factor out an h and reduce it with the h that's on bottom. Okay, so that would be equal to the limit as h approaches 0 of h out front, 2x plus h over h. Reduce those and plug in the h, we get 2x because the h goes to 0. So the derivative is 2x. Now, if you're a little more advanced in your knowledge of derivatives, you could have taken that without the definition of the derivative. Okay, so now to the meat of the problem. We've got a point Q that the tangent line passes through. Okay, and it says find all points P where this is true. Okay, so the point Q is not on this function. It's not, like if we plugged in a 0 here for x, we would not get 3 as an answer. This Q is somewhere else. So we've got these tangent lines. We've got, well, first of all, we've got this parabola. It's been shifted up here. Okay, so that's up there somewhere, and we have this point 0, 3. Let's see, so that would be here. Okay, so it's asking us where we need a tangent line, or maybe more than one tangent line, that passes through that point. Okay, so a possibility could be here. Okay, so the tangent line would be the tangent at that point on the graph, but that goes through this point over here. Another possibility would probably be over here. Okay, those are just estimates. We don't know exactly where those are yet, but I just wanted to point out that this is not on the curve. Okay, this is not on the parabola x squared plus 7. This is somewhere else. Okay, so you'll find these tangent lines, but they have to pass through this point, this 0, 3 point. So how exactly do we do that? Well, we're going to use the y minus y1 equals m times x minus x1. Okay, and we are going to plug in, we're going to use the information that we have to plug in. So the first thing that we have is we have the function f of x equals x squared plus 7, and we have this point. So let's plug in the function in place of y. So that will give us an x squared plus 7. That's in place of y. Remember, f of x is the same thing as y. Minus, and we'll use the point here for our x and our y, and we'll set them equal to one another. So for the y, we have 3 equals our slope. What's our slope? Well, we have a 2x slope. We don't know anything more about it. That's our derivative function, so we'll just keep it as 2x for now. And then we'll do x minus, what's the x value that we plug in? Well, we plugged in a 3 for the y value because of this, so let's plug in a 0 for the x value. Okay. So when we do that, let's clean that up a little bit. X squared plus, what would that be? 4 equals, looks like 2x squared. Okay, so we can move the x squared over. We get 4 is equal to x squared. So x is equal to, what's a square root? Well, remember when you square root, you have to put a plus or a minus out front. So it's plus or minus 2. So we have two different x values. We need to find the y values that go with them. Okay, well, we know the y values are going to be on this curve, okay, because they're tangent lines. So we could say, okay, well, we have 2. So what is f of 2? F of 2 is 2 squared plus 7, which is 4 plus 7, which is 11. So one of our points that we have on the line is 2, 11. And the other one would be, well, we plug in a negative 2 here. And that's equal to negative 2, 11. Well, we could plug it in. But negative 2 squared plus 7 is also equal to 11. So we get negative 2, 11. Okay, so those are our 2 points that pass through. Okay, so this is P and this is P. Okay, 2 points that have tangent lines that pass through this point Q. And we aren't asked to find the actual tangent lines, so that's it.